problems to do dealing with right triangle trigonometry still, but now we've got some application problems. So distance at sea from the top of a 200-foot lighthouse. So I'm going to start by drawing my lighthouse, 200 feet. The angle of depression to a ship in the ocean is 23 degrees. So I'm going to pick a spot here for my ship. I know I could have drawn a little cute little picture. You got to think about what the angle of depression is. So you can kind of envision that we would have this triangle that would look something like this. Imagine the lines are straight. So I'm drawing a right triangle. Now, if you were up here in the top of the lighthouse and you were looking down at that ship, the angle of depression is the angle that's formed with a horizontal and then down to your line of sight. So you do have to be careful with an angle of depression. The tendency is to want to put it in here inside the triangle, but it's not. So imagine you are at the top of the lighthouse, and from looking straight out and then looking down towards the ship, this is the angle of depression. That's the 23 degrees. Now, from geometry, you know that this also would be a right angle. So if that is 23 degrees, then we know that inside here would be 90 minus 23. So this would have to be 67 degrees. Or you would also know that this would be a parallel. My dashed line here is parallel to this line down here. And this is a transversal. When you have parallel lines cut by a transversal, then you have alternate interior angles are congruent. So you're going to need to recall some things from geometry. So now I have my angles of my triangle. And my question is, how far is the ship from the base of the lighthouse? So that would be this distance here. Here's the base of the lighthouse. Here's the ship. I'm going to call that D for distance. So now I'm trying to figure that out. And I could use either angle, which means I could use either, I'm going to be using probably tangent or cotangent, but I don't think we want to do that. So I want to do opposite over, actually I would either use the 23 degree angle or the 67 degree angle. And using tangent, it's opposite over adjacent. I'm actually going to use the 67 degree angle and say tangent 67 degrees equals D over 200. And the reason for doing that is if I used the 23, which I could, tangent 23 equals 200 over D, but then I'm going to have the D in the denominator, and you probably would rather not do that. So then we get D equals 200 times tangent 67, and we're going to grab our calculator. So now we can do 200 times tangent 67, and we get that D is approximately, I'm not told what to round to, so I'm just going to say 471.2, and that would be feet. Make sure you use units when we're dealing with these application problems. By the way, since I got you here, which is kind of silly to say, somebody asked, how do you find like cotangent or cosecant or cosine on your calculator if you had to evaluate that? So this is nothing to do with this problem. If we wanted to know, say you wanted to find cosecant of 25 degrees. There is no cosecant button. And when I want to make sure that, because this was the question somebody asked, well, do I just use this inverse sign right here? No, because that's something else. It's important, but something else. What you want to think of this as is 1 over sine 25, because remember cosecant is the reciprocal of sine. And then what you would do is you could do sine 25 degrees. You could do that and get your answer. And then this x to the minus 1 button, this is a reciprocal button. And that will just flip whatever you had over. Or you could just do a fraction and do 1 over sine 25. And if you do that, you get that same answer. So in case you were wondering, but this has nothing to do with that problem I just did. So, okay. Next problem, except let me get this back on here. All right, so the next problem we have the height of a tower By the way, I didn't say what page this is. I'm on page 455, the application problems. These are in your textbook. A 600-foot guy wire is attached to the top of a communications tower. If the wire makes an angle of 65 degrees with the ground, how tall is the communications tower? So I'm going to draw this for my tower. I don't know how tall that is. I'm going to call it that H for height. I have a 600-foot guy wire attached from the top of the tower, and then it's attached to the ground. So it's going to be over here somewhere. And so I have my right triangle. I know that the wire is 600 feet long. And I know that the angle it makes with the ground, well, here's the angle it makes with the ground. So I get 65 degrees. So you're going to notice on every problem I do on these, make a picture, make a picture, make a picture. And it's going to be a right triangle. So now we can figure this out. Notice that I have my angle 65 degrees. I have opposite and hypotenuse. So I want to use sine 65 degrees equals H over 600. So we get H equals 600 times sine 65 degrees. These are not 30, 60, 90 triangles or anything, or 45, 45, 90. So we're going to have to use our calculator to evaluate those. I hope you memorize those special values. It's important. And we get H is approximately 543.8 feet. So that's how tall the tower is. Okay, next problem. Determining a distance, a woman standing on a hill sees a flagpole that she knows is 60 feet tall. So that's this right here. So from here to here, we know is 60 feet. The angle of depression to the bottom of the pole. So notice here's her line of sight. So straight across from the horizontal, but the angle of depression down to the bottom of the pole is 14 degrees. And the angle of elevation to the top of the pole, so looking up, then she can see that that is 18 degrees. Find her distance from the pole. So we are looking for this distance here. Okay, so we're going to think about how we're going to do this one. This one's a little more complicated, so you'll need to make sure you're following along really carefully. Notice that I have two triangles, two right triangles, this upper one, the lower one. And I'm going to think of this, if I think of this value right here, of this top triangle piece, I'm going to call this distance y from this part here. Well, then think about what would this be called? If the whole thing is 60 and this piece is y, then this other piece would have to be 60 minus y. So hopefully that makes sense to you. So now I'm going to write out two trig equations for this. Let me make this a little thinner line. So if I start with the 18-degree angle, it's going to be opposite over adjacent. So that's tangent. So I'm going to have tangent 18 degrees equals y over x. Then for the lower triangle, I'm going to have tangent 14 degrees equals opposite, which is 60 minus y over x. Okay, so then remember we're trying to find her distance from the pole, so we're trying to find x. What I'm going to do next though, because it's going to be easiest to just think of like fraction busters to clear out the denominator. So if I multiply both sides by x, I'm going to have x tangent 18 degrees equals y. And on this one, I'm going to have x tangent 14 degrees equals 60 minus y. So this one I have solved for y. I'm going to solve this one for y. Since it's a minus y, I'm going to think of, hopefully you can arrange this in your head, I'm going to add y to both sides so it moves it over here. And then I'm going to subtract the x tangent 14. So I'll have 60 minus x tangent 14. Okay, now y equals this and y equals this. So what I can do next is I can actually say, I'm going to set them equal to each other. So that means I can say x tangent 18 degrees equals 60 minus x tangent 14 degrees. Okay, so again, since they're both equal to y, by substitution, I could make them equal to each other. We did this in algebra too, except our equations were not as complicated. They didn't involve trig functions. Remember, we're trying to solve for x. So I need to get the x's on the same side. So I'm going to do that. So I'm going to add this x tangent 14 to both sides. So I get x tangent 18 plus x tangent 14 equals 60. Now I've got an x in both terms here, so I'm going to factor out an x. So I'm going to have x times tangent 18. Remember, this is just a number that we're going to use our calculator to evaluate, plus tangent 14 equals 60. This is multiplied. I want to undo multiplying by this expression, so now I'm going to divide both sides by this sum of these tangents. So I'm going to have 60 over tangent 18 plus tangent 14. Now you can come to your calculator, so be really careful when you do that. Let's see, why isn't that not? Whoops, that didn't do it. There we go. So we're going to have a 60, and in the denominator we're going to have tangent 18. You do have to remember to close the parenthesis before you go on, or you will have a wrong answer. Tangent 14. If you forgot the parenthesis here, it wouldn't matter, but be in a habit. And so I get that x is approximately 104.5. I don't know if they said anything to round it to. No. And this would be feet. Definitely a more complicated problem, but still going back to our picture and making right triangles and just a little bit more involved mathematically. All right, going on here. So for this one, we've got an airplane is flying at an elevation of 5,150 feet directly above a straight highway. Two motorists are driving cars on the highway on opposite sides of the plane. The angle of depression to one car is 35 degrees, and that to the other is 52 degrees. How far apart are the cars? So I'm going to draw a vertical line representing the height of my airplane. So this is 5,150 feet. Then I've got an angle of depression of 35 degrees. Remember that is always measured from the horizontal. So this is the airplane right up here. So if I have an angle of depression of 35 degrees, I'm going to make that something like this. So this would be the 35 degrees angle of depression, because it's always measured from the horizontal down to that line of sight. So then this would represent one of the cars. So we'll just put, we'll call this car 1. And then we have a 52 degree angle of depression, so it's a little larger. So I'm going to draw something like this. It's not curved though. And that's 52 degrees. And so then I'm going to make this car 2. This is a right angle, and this is a right angle. The height of the airplane, that's what this 50, it's kind of confusing though, that's this piece here, 5,150. And what are we asked to find? How far apart are the cars? So we're trying to find this total distance here. The picture is definitely necessary because we have to be able to figure out what we're dealing with. But now notice that as far as working with the triangle, this is 35 degrees. I either want to use this angle down here. And remember, parallel lines cut by a transversal means this is also 35 degrees. And this is 52 parallel lines cut by a transversal, so this is also 52 degrees. So you can use that for your angles, which also means, of course, that we know what this is as well. So if we wanted, because we have a right angle right here, so this would have to be 55 degrees here, and this one would have to be 38 degrees. So we can get all this information. Ooh, this is kind of nice later, but yeah, it won't help us now because we're only dealing with right triangles right now. And as a whole, this whole thing is not a right triangle because notice 35 degrees, 52 degrees, and the sum here is clearly not 90 degrees. So we are dealing with two separate triangles, but soon we'll have a way to avoid doing what we're going to do next. Okay, so we have to find how far apart the cars are. So I'm going to, let's see, if we're going to have to use our triangles to find some information. I had to pause it so I could see it, but some of you may have already seen it. We know this piece right here. So if I use this 35-degree angle, then the 5,150 is the opposite side. And then I have this, I'm going to call this D1, and I'm going to call this D2. And then that way we can get the sum of those. So my first triangle, the one on the left, I'm going to have tangent 35 degrees, since I'm dealing with opposite and adjacent, is 5,150 over D1. I want to solve for D1, so I'm going to multiply both sides by D1, so that means the D1 will be not in the denominator, but then I'm going to divide, oh, not DI. Okay, but then I'm going to divide by the tangent 35, so we're going to have 5,150 divided by tangent 35 degrees. So that's my first distance. For my second distance, to figure out this piece, if I use tangent 52, so I'll have tangent 52 degrees equals the opposite, which is 5,150, over adjacent, which is D2. So then if I move this out of the denominator, I'm going to have D2 equals, and I'm going to divide by the tangent 52. If you have to show that, that's fine, but hopefully you can follow that. Now you might wonder why I'm not doing each part. There's a reason why here. We know that D equals the sum of those both parts, so 5,150 over tangent 35 degrees plus 5,150 over tangent 52 degrees. Now I'm going to grab my calculator and do both of those things. So I have 5,150 over tangent 35 plus 5,150 divided by tangent 52, and we get that D is approximately 11,370, we'll just say 79 feet. Now, the reason why I didn't do the separate ones and add them together is I would have rounded, and then I would have rounded, and then I would have rounded. You really want to just try, when you have multi-step problems, you are better off just rounding one time at the very end, so try and get in that habit. All right, next one. We've got a hot air balloon is floating above a straight road. To estimate their height above the ground, the balloonists simultaneously measure the angle of depression to two consecutive mileposts on the road on the same side of the balloon. The angles of depression are found to be 20 degrees and 22 degrees. How high is the balloon? So let's draw a vertical here for the height of the balloon. So my balloon is right up here. And this time they're sighting from two consecutive mileposts. One is 20 degrees angle of depression and one is 22. So I'm just going to draw, I should probably be using my straight line tools. And then the other one, and they're actually really close. Yeah, this is not working. I'm going to come up with a better picture, so hold on. Okay, so I sketched a few pictures while I had you paused. And the situation is, you got these two triangles because you have, here's my 2 mile markers. So here's mile marker 1 and mile marker 2, we'll call them. And But the picture gets really muddled sometimes when you have those triangles. So what I did is I separated it out into two triangles. I have this height of the balloon common to both of them, but one of them I showed an angle of depression of 20 degrees, which remember that means that this angle inside the triangle would also be 20 degrees because parallel lines cut by a transversal form alternate interior angles that are equal or congruent. Same thing here. If you have an angle of depression of 22 degrees and this is 22 degrees, then, well, that makes this 22 degrees. So now I have these two triangles, but I need something else. I need another piece of information. Now the piece of information that I'm going to use, because I don't know this horizontal distance, I'm trying to find out how high the balloon is, but I need another side. So here's my other piece of key information. They are consecutive mile markers. So that means that this distance right here is 1 mile. So if I were to say, and let's see, the one that is the 20, if it's the one that has the angle of depression of 20 degrees, that's going to be farther out so this is going to be mile marker 2 on this corner, and this would be mile marker 1. I have to pause that and make sure I'm right. Okay, I'm right. So, so that means if I wanted to call this x, this distance, then, because that would be this distance right here, then this distance right here would be x plus 1, because it's just one more mile out. So now I have something that's going to be similar to what I did on that last problem, where we will be able to come up with these equations. So what do we have? I'm going to be using tangent again. So tangent 20 degrees equals opposite over adjacent. And for my other one, I have tangent 22 degrees equals opposite over adjacent. So I get that. So here's my two equations I have to work with. Remember, we are solving for h. So, but what's going to happen in this one, I think we're going to end up solving for x first and then go back and find h. Because when I multiply both sides, now keep in mind I have to keep the x plus 1 together. So I get x plus 1 times tangent 20 degrees equals h. And over here I get x tangent 22 degrees equals h. So now they're both equal to h, so I can set them equal to each other. So I'm going to have x plus 1 tangent 20 degrees, remember tangent 20 degrees is a number, equals x tangent 22 degrees. Okay, so we're going to end up solving for x, and then we'll have to go back and use one of these equations to find h. If you remember, I know we've done this at some point in this class where we did a problem where there were 3 steps, and it was distribute, regroup, and factor. And I'm pretty sure I said, we'll do this again. Well, here we are. We're doing it again. So remember, this is tangent 20 times x plus 1, so we have to distribute this, and we get x tangent 20 degrees plus tangent 20 degrees, 1 times that, equals x tangent 22 degrees. That was my distribute. So I distributed tangent 20. I didn't have to distribute on this side. Now regroup. So when I say regroup, get the x's on the same side. So I'm going to subtract this to the left side, and I'm going to subtract the tangent 20 to the other side. So I have x tangent 20 minus x tangent 22 equals, and when I subtract it over here, it's going to be negative tangent 20. That was my regroup. Now I factor out the x, and I get tangent 20 minus tangent 22. And now I solve for x by dividing. So I get x equals negative tangent 20 degrees over tangent 20 degrees minus tangent 22 degrees. And when we do that, I'm going to pause this. All right, so I got approximately 9.087. Remember, this is not my answer. So let me tell you what I'm going to do. I'm going to actually store this. See this button that says STO above the on key? I'm going to hit that. And I'm going to store this. I don't really want to store it in X because a lot of times X gets used for other things. So I'm going to store this. I'm going to hit alpha and then A. I'm going to store this in A. Okay, and you'll see why in a minute. So, so I'll make a little note. Store in A. So now I'm going to go back up to see what I'm, let's see, I'll use this one. So we know that tangent 22 degrees equals h over x. Oh, I guess I could have used this one. H equals x times tangent 22. Oh, so actually I didn't need to store it because I have it stored right already there. So then h is, I'm going to leave this on my calculator and multiply by tangent 22. But now you know how to store something in case you ever need it. So I get h is approximately 3.67, and my units were in miles. So that would be the height. What were we even talking about? The height of a balloon. That's a long problem. So there's a lot for you to look at there. I will save these notes as well for you and post them. Oh, no, because you're supposed to, yeah, I'll do that. Okay, I'm going to do that. Okay, so I think that's going to be it for examples. And I am going to, when you have an assignment tomorrow, so I am going to post these notes on to when I post tomorrow's assignment so that you can reference those in case your notes are missing something. So that way you'll have access to that as well. So continue please to contact me if you have questions on the homework, and I can always do a quick video of some other tips or helpful hints. Hopefully you can kind of communicate with each other and help each other out. So I know it's kind of tough times, and hopefully we will get through all this. See you later.